people packets in the physical field like this. System permitted to calculate for numerical analysis. And NK means number of tickets, so one is input rate of field and so on. Finally, we can see that this figure is the mean waiting time is the traffic intensity of people traffic. And its mean waiting time is increased and double exponentially. This scale is logarithm scale. So if this traffic intensity is number of chickens and times inflate of people traffic during a cycle time. To translate this traffic mode, we can get one cycle, two cycle, and three cycle in blue line, and so on. This figure shows the number of waiting packets in first and second queue or queue people traffic. These contributions of this paper, we derive maximum cycle time and 2.8 times of one frame time and in the range of 60 km and so on. And we investigated the packet delay or people traffic in case of this. I am planning to study the packet loss performance quality tree model with applications and performance analysis of the OLT installation of IPTV services. Yes, sir.
Is there a question on this paper?
Yes.
From your delay analysis,
Yes.
you point out that
Yes.
there are trade-off between research and
Yes,
time.
okay.
I want to know
Yes.
what's more important in industrial?
Industrial.
Yeah.
In the implement the gear sequence system is fixed cycle time. Yes, only operators can adjust the cycle time in our system. But it's very in gear case not important. It's because fixed. But in this our study is very heuristic. Okay, so I can say that it is important. It is important to trade between batteries use and delay.
I have one more question. You derive the cycle time of this for the G-port.
Yes.
The cycle time is changed dynamically or is it fixed at derivation?
Yes, but there is a random variable. But in numerical analysis, we take the maximum cycle time. It is very hard to find the result. It's in your random variable of cycle time.
Any question? Thank you. Ms. Ma. I will introduce next speaker. The title of this talk is Implementation of Engine Resource Control Function with QoS Mapping Mechanisms. The speaker is Jin Soo-jeon. Soo-jeon is from the Department of Computer Engineering under National University Korea. Let's welcome Soo-jeon.
I start my presentation and subject to the implementation of engine resource control functions with QoS mapping mechanism. This is content. One, introduction to QoS mapping rules, its session and engine resource control protocols. Three, implementation and test bed for engine resource control protocol. Findings, summary. Introduction. First, engine. Engine integrates various existing communication networks to offer quality-preventive broadband multi-use services in IP environment. This figure shows engine architecture. Service control functions performs video resource control, session control, registration, and authorization and authentication at the service layer. There are transport control functions and transport functions at transport layer. Transport control functions composed of network attachment control functions and resource and permission control functions. Network NHA Nugget manages user registration information and access network information. Nugget interacts with transport functions to perform admission control of transport resources. There are transport resource control function entity, and policy decision function entity in Nugget. Transport functions include transport resource enforcement function entity and policy enforcement function entity. Engine resource control protocols. In IQT study group 11, engine signaling requirement and protocol is standardized. RS interface between SCF and resource control, transport control functions defines resource control function for AAA authorization and authentication and accounting for AAA. And RS interface, resource control protocol for RS interface defined in Q.3301.1 based on the ITF times protocol and RW interface between transport control functions and transport functions is used to allocate and related resource or transport network. For RW interface, IQT has defined 3 resource control protocols based on CAPS in Q.3303.1 and A.24A in Q.3303.2 and diameter in Q.3303.3. SCF is required to map QoS information elements between session initiation protocol and resource control protocol. IQT has focus on definition of resource control protocol for its engine interface, but it's not, it has not, but it has not made much process in mapping mechanism of SS and QS information elements in RS or RSN RW interface. Contribution. We designed an implementation of resource control protocol for RSN RW interface using time protocol and suggest mapping rules between time to information elements and session description protocol attributes for QS-based resource control in NGN. NGN led to test bed using resource control protocols, NJC is Java-based C program, and laptops with deep serve capability. We compound the NGN resource control functions which are able to offer differentiated transport services based on our proposed mapping rules or QS information element. Two, QS mapping rules between session and NGN resource control protocols. The application service class in SCF can be used network class of service for driving network QoS service for LAGE, but its definite extraction method is not defined in Q.33 or 3 or 1.1. Therefore, we devised our own methods that LAGE drives network class of service from media type, flow status, IP address information elements in RS interfaces. SGF extracts media type, flow status, IP address information element from SDP and it passes these elements to LAGE. LAGE performs the final automation control by providing LAGE with IP address from SGF to get the corresponding user's transport to register information. And LAGE derives network class of service and IPQS handle value by referring user level and RS interface information. Three, implementation and test bed of NGN resource control protocol. These videos show relationship among client server and application when diameter is used in RS and other interfaces. Instead, the chip server session control protocol and diameter RS client and SCF RCAPP and SCF consists of diameter RS server and diameter other client and LAGE RCAPP. SCF RCAPP performs resource control application by mapping message and QS information elements between SIP and diameter protocol. LAGE RCAPP mediates message and information elements in RS and RW interface. There are PFP, RCAPP, and RW server that are in PFP or switching or routers in transport layer. PFP enforcement resource control decisions project on Java.NET JDiameter project support APIs for diameter-based protocol, but it does not support API for session, authorization, and authentication. Session state machines required to have as fundamental functions to handle session in diameter, and authorization and authentications are required in RSA interface. Therefore, we use both API was one in JDiameter-based protocol and additional design, diameter session, and authorization functions for engine resource control. This is in diameter. Session, the AA session class is designed to handle session not support in JDiameter, and is managed by session managers. The AA session includes session state machine changed by event through session event listener. And in addition to basic messaging by support JDiameter, and we design supplemental request and response message for resource control application in engine resource control testbed. This video shows engine resource control testbed with protocols of RS and other interfaces, and session control protocol, and routers with deep server capabilities. C is running on the session session protocol that is running on session service